Hello guys, welcome back to another video. In this video, we will understand about rate limiting and then we will create a custom rate limiter. Have you ever heard about server crash? One of the most common reason server crash occurs is because of DDoS attacks. DDoS attacks are a huge number of traffics sent to your server. When your server cannot handle this traffic, then your server becomes inactive, which is most commonly referred to as server crash. To protect server against such attacks, rate limiting is used. Rate limiting does exactly what the name suggests. It limits the number of requests made from a specific IP address. Now, let's dive a bit deeper about rate limiting. So first of all, let us visualize what happens when we don't use rate limiter. So let us suppose this is your server. So this is your server. And then you have different clients. So this is one client. So this is client 1. And then similarly, you can have different clients. So this is client 1, this is client 2, and then this is client 3. So this is client 2, and then this is your client 3. So now each of these clients can have different IP address. So IP address is a unique identification number for different clients. So let us suppose the IP address for client 1 is 192.168.1.1. And similarly, IP address for client 2 is, let us put this as 168.1.2. And similarly, the IP address for client 3 is 1.3. Okay, so we have different IP address for all of these clients. Now, let us suppose that your server can handle only 5 requests for one IP address per minute. So the maximum capacity that your server can handle is 5 requests per minute. So in 1 minute, your server is capable of handling just 5 requests from one IP address. So if your client 1 sends more than 5 requests to your server, then your server will crash. So let us suppose that at time 10 seconds, your client 1 sends first request to the server. And then in, let's say, time 22 seconds, it sends another request. And similarly, it sends another request at 40 seconds, another request again at 55 seconds. So it has already 4 requests. Now, when it makes one more request, the server is running at its maximum capacity, which is 5 requests, which has been made under 1 minute from a specific IP address. Now, as soon as client 1 sends another request, its 6th request to the server, then your server can no longer handle the request and your server will go down. This is called server crash. Now, since your server has gone down, the client 2 and client 3 can no longer make request to the server and basically your platform or application will be down. So this is the problem that rate limiting is trying to solve. Now with rate limiting, what it does is, let us suppose this is your server. And similarly, let us create a client. So what rate limiting does is, it becomes one intermediate interface between your server and client. So server can only handle 5 requests per minute from specific IP address. And now, when client makes first request, the rate limiter allows the request to go to server. And when it makes the second request, it allows the request. Similarly, it allows the third request. It also allows the fourth request. And lastly, it allows the 5th request. Now, as soon as client hits another request to the server, which is its 6th request under 1 minute, so as soon as the client makes its 6th request, the rate limiter will block that request and it won't let the request pass to the server, because if 6th request go to server, then the server will crash. So what it does is, it will just reflect back the 6th request and send a unsuccessful message to the client. This way, your server will be up and running 24/7. Now, let me show you how we are going to approach this rate limiter. So first of all, let us assume that we have 2 users, user A and user B. So this is user A, and then we have user B. Now, the IP address for user A is, let's say, 192.168.0.1. And similarly, the IP address for user B is 192.168. Let's say to whatever it can be. So these are the IP address for these users. So now if user A makes 3 requests at say time T1, T2 and T3, and user B makes request at T4 and T5, then we are going to store that information in a map, and map looks something like this. So this is how a map looks like in JavaScript. So as a key, we will store their IP address. So first of all, let us create the data for user A. So when recording the request made by user A at time T1, T2, T3, it will be stored like the key will be the IP address of the user. So the key will be 192.168.0.1. And then as a value of this map, we'll create an array and then store the timestamp. So timestamp can be anything, a random number, which is going to be the date time. So this is the time, or this is the timestamp that user made the first request, and this is the timestamp that user made the second request, and similarly this is the timestamp user made the third request. So similarly, we'll store the information or the request made by the second or user B. So we will store in the same way. So the key will be the user's IP address, and there will be a timestamp for the request made by user B. So user B made 2 requests, then we will store 2 timestamps for this IP address. So this is how we will be storing all the requests that a user has made. And if the length of this timestamp is more than 5, which the user had made request below 1 minute, then we will throw error. So this is how we are going to approach in code to implement the rate limiter. So now let us actually code and see how to create a rate limiter and how to block the extra request that has been made to the client. For that, I will open my terminal, and in my terminal I will navigate to projects. So I'm in my projects, and now I will create a directory called mkdir. The directory name will be rate limit 01, and let us go inside that rate limit 01 directory, and I'll open that in Visual Studio Code. So once I open the rate limit in my Visual Studio Code, now let us first of all create a very basic Next.js application. So let us create a very basic Next.js application. So to create very basic Next.js application, we have npx create next app, and we want the latest version. So now it will ask me several things like the project name. I want all the files to be in this directory, and let us put the default configurations. So I will see you when the Next.js application has been created. Okay, my Next.js application has been created. Now let us create a very basic API route. So under the app, I'll create a subdirectory called API, and under that I'll create a endpoint called hello and route.ts. So I assume you have familiarity with Next.js 15 app router. So now let us create a very basic function that will handle the get request on this particular route. So export asynchronous function get request, and it will accept the request parameter, which is going to be of type next request, and basically we want to send a Next.js response. So next response.json, and then we will send success as true, and let us also send a message called subscribe to let me console you. If you haven't already, please do this. Now let us check this API endpoint. So let us start our server. So npm run dev, and now let us open our browser, and let us hit this particular endpoint. So localhost 3000/API/hello. So when we hit this endpoint, we should get that message. So we can see that we're getting that message. Now let us assume that the power of our server is that it can only handle 5 requests in 1 minute from a specific IP address. Now when I send more than 5 requests now, obviously we get the response back. Now what we want to do is, if our server is only capable of handling 5 requests under 1 minute from a specific IP address, then I want to block as soon as the user hits the 5 request, meaning if it hits the 6th request, then I want to block that. And so to do that, I need to create a rate limiter. So to create a rate limiter, we can use a middleware with middleware.ts. So middleware is a file that runs when you send a request from a client up to the point it reaches the server. It has to go through middleware. So I'm going to create a middleware.ts, and as soon as I create a file with this middleware.ts name, Next.js app router will automatically recognize that this is the file I should go before going to the server. Okay, now let us create our rate limiter. So first of all, as I showed you in before, we need to create a map to store the data about when the user made request to the server. So we will be creating a in-memory store for now. So let us create a IP request map, and this is going to be of type map, and there we will have key as string, and then we'll have array of number. So this is going to be the timestamps, and this is going to be the IP address. So we have created IP request map. Now let us create two variables. So rate limit window. So rate limit window is the time that we want to set. So I want 1 minute. So 60 times 1000 will be 1 minute. And then I also need to create a variable called max request, where I will store the maximum capacity of my server. So max request equals to 15. So this means that 15 requests. So now I'm assuming that my server can only handle 15 requests in 1 minute. If you want, you can set this to 5. So my server will be capable of handling maximum 5 requests in under 1 minute from a specific IP address. Now we need to create a function called middleware, which will run as soon as we hit request from the client side. So before the request reaches the server, this middleware function will be run automatically. So export function middleware, and middleware will get request from the client. So next request, which comes from next server. And now what we need to do is we need to get the IP address of the client so that we can check if more than 5 requests has been made by that specific IP address. But to do that, we need the IP address of the user. So to access the IP address, what we need to do is the IP address can be accessed from request.headers.get x forwarded for. So when you are deploying your Next.js application in Vercel, then we can get the IP address from this specific header. So x forwarded for. And we need to also split it. So so basically this is going to be, there will be specific there will be other unnecessary information that we will access when we use this header. So we only want the IP address. So by doing this, we can access just the IP address. And next thing, if it is not deployed in Vercel and we are using in our local machine, which is something that we are doing now, we can get the IP address from request.ip. And if we cannot access IP address from this both above, then we can put the IP address as unknown for now. So obviously this will yell at me. So what I can do is I can ignore this. So ts ignore for now. So I have the IP address. Now I need to keep track of the current time. So let us store this in the variable current time, and the current time we can access via date.now. So this current time has the current time, and we have the user's IP address. Now we need to check if user is visiting our website first time. So to do that, if user is visiting our website first time, then its data will not be present in this request map. So let's check that. So if the user's IP address is not in the request map, IP request map, then we need to put its data to this IP request map. So to put the data, we can do IP request map dot set IP address, and for the timestamps we can set empty array. So at the beginning, the user's key will be the IP address, and basically it will have no timestamps. Now this is the case if user is visiting first time. Now if user is not visiting the first time, meaning it has already made some request in previous time, then we need to we need to check if it has made more than 5 requests. So to do that, what we can do is from IP request map, we need to get the data of that specific IP address. So get that specific IP address. Now we have access to value and we can filter it. So filter and filter. So we have, by doing filter, we iterate over the timestamp. And for each timestamp, we want to check if the current time minus timestamp is less than rate limit window. So what we are doing is that we want all the timestamps which has been made under 1 minute. So this will filter me all the timestamps for this specific IP address under 1 minute. And let us store this in the variable called timestamps. So now if the length of timestamp is more than or equals to max request, which is 5, then we should not let user hit this endpoint. So let us create that condition. So if the length of timestamps, so timestamps.length is greater or equals to max request, then we'll immediately send the Next.js response as so next response from next server, and we will send the message as too many requests, please try again later. And then we can also send status as 429. So 429 is the status for rate limiting. So timestamps.length, so it is yelling at me, so I need to say that this is not going to be optional. So timestamps with have length. So what I can do here is I can set this as explicitly as this will have a value, and now this will not yell at me. So after doing this, so if user has already made more than 5 requests under 1 minute, then we will return this error status, and if not, we need to allow user to hit that endpoint. So we can now do timestamps, but also we need to push the user's current time to the timestamps because we need to check the same thing for the next time. So we have updated the timestamps, but again we need to store this timestamp in the IP request map. So IP request map dot set the IP address as timestamps. Okay, so now after doing this, we need to allow the user to hit that API endpoint. So next response dot run the next thing. So okay, so this is it. Now we also need to paste some default code that middleware.ts file expects, which you can obviously get in many of the projects. So this is something that you use in every middleware.ts file for Next.js project. So this is our main logic for the rate limiter. First of all, we're extracting the IP address from the client. We're extracting the IP address, then we're checking if user is visiting the site for the first time, and if so, then we will set the IP address and we will set the timestamp as empty, and then we will extract all the timestamp, all the request that has been made by the user under 1 minute, and if the length of this timestamp is more than 5, then we will immediately send the response as too many requests. Otherwise, if not, then we will update the timestamp and finally push the timestamp in the IP request map for that specific IP address, and then we'll let the user to hit this endpoint. So now let us test our rate limiter if it is working correctly or not. So let us open our browser, and now let us hit more than 5 requests and let us see if we can access the endpoint or not. So first request, second request, third request, fourth request, fifth request. Now if I had hit another request, it should send an error message. So okay, we can see that my request is not sent to the route. So before my request is sent to this function, I am getting this response. So my application is not letting my request to go to this function. So I'm not able to access the resource from the server. And in this way, my server can stay alive 24/7 running. So this is all. I hope you understand the concept of rate limiter. So I'll see you in the next time. Thank you for watching the video.